So here is a question, and we have to find which of the following numbers are not perfect cube. If you want to solve these questions, you can pause the video, and I'm going to solve question number 1, part 1 first. So part 1 is we have to show whether 216 is a perfect cube or not. So what we will do, first we will find the prime factors of 216. So prime factors of 260. So let's find out 216. First we will divide by 2. So this will give 108. Again by 2. This will give 54. Again by 2. This will give 27. Now by 3. 9s are 27. 3. 3s are 9. And 3 1s. So prime factors of 216 are 2 into 2 into 2 into 3 into 3 into 3. 3 times 2 and 3. Okay. So here all the factors are in group of 3. Okay. 2 is also in the group of 3 and 3 is also in the group of 3. So 216 is a perfect cube number. Okay. Now second part is 128. We have to show whether this number is perfect cube or not. So again we factor of 128. So 128. We will divide it by 2 first. So 2 6 are 12, 2 4s are 8, again by 2, 3s are 6, 2s are 4, again by 2, 1s are 2, 6 are 12, again 2, 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So here we have so of prime factors of 128 is 2 times 2 times 2 times 2 times 2 times 2. 3, 6 and 7. 3, 3, 6 and 7. So we see that factor 2 does not appear in 3's group. Okay. This 2 is not in 3's group. So this is not a perfect cube. Therefore 128 is not a perfect cube, right? Now third part, you try to solve this. Now we have 1000 and we have to show that whether this is a perfect cube or not. So what we will do, we will again find out the prime factors of 1000. So we will divide it by 2 first. This is 2 5s are 10, 0 0. Again on dividing by 2, we will get 2 5 0. 2 1s are 2, 2s are 4, 5s are 10. Now it is divisible by 5. So 5 2s are 10, 5 5s are 25, 5, 5 and 5 1s are 5. So here we have 3 times 2 and 3 times 5. So prime factors for 1000 are 2 times 2 times 2 times 5 times 5 times 5. Right? Now here we see that all the factors are in group of 3. 2 is in group of 3 and 5 is also in group of 3. So 1000 is a, therefore 1000 is a perfect cube. Okay. Now question number 4. Two times 2 and 2 times 5, right? So the 2 and 3 are not in group of 3. So 100 can be written as 2 times 2 times 5 times 5. So 2 and 5 are not in group of 3. So 100 is not a perfect cube. Question 5 is, this is a big number, 4, 6, 6, 5, 6. Is this a perfect cube or not? So what we have to do, first we have to break it into a prime factors. Divide it by 2 first. This will give 2 is a 4, 3 is a 6, 3 is a 6, 2 is a 4, 8 is a 16. Again by 2, 1 is a 2, 1 is a 2, 6 is a 12, 6 is a 12, 4 is a 8. Again by 2 will give 5 is a 10, 8 is a 16, 3 is a 6, 2 is a 4, 2 is a 4, 9 is a 18, 1 is a 2, 6 is a 12. 2 1 is a 2, 4 is a 8, 5 is a 10, 8 is a 16. Again by 2 will give 7 is a 14, 2 is a 4, 9 is a 18. Now this is divisible by 3. So this will give 2 is a 6, 4 is a 12 and 3. Again by 3 this will give 8 is a 24. Now 3, 2 is a 6, 7, okay, why it's not working? Let me take another color. So 7, now 3, 9, and 3 3s are 9, 3s are 1. So here we have this 3 3 group, 3 group, and 3 group. So 4 6 6 5 6 can be written as sum of prime factors 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3 times 3 times 3, right? Now here all the factors are in group of 3. These 2 are also in group of 3. These 3s are in group of 3, and these 3s are also in group of 3. So 4, 6, perfect cube. Now question 2 is find the smallest number by which each of the following numbers must be multiplied to obtain a perfect cube. So these numbers are not perfect cubes and we have to find by which these number must be applied so that we can obtain a perfect cube. So first part of this question is 243. So what we will do, we will find the prime factors of this number 243. So prime factor for this is if we divide this number by 3, we will get 8, 1. Again on dividing by 3, we will get 27. Again this will give 9. 3 3s are 9 and 3 1s are 3. So prime factors for 243 are 3 times 3 times 3 times 3 times 3 times 3. 3 and 2 5. 3 and 2 5. So this is the prime factor for 243. Now we can see that these three are in 1 1 2 3. These three are in set of 3 and these threes are in set of 2. And to make this number a perfect cube, if we multiply by 1 3 more, so these 3 will also be in group of 3 and this number will become a perfect cube. So 243 must be multiplied by 3 to make perfect cube. Okay. Now second part is 256. So if you want to give it a try, you can pause the video. Now 256. If we find out the prime factors of this number, so 2 ones are 2, 4 twos are 4, 2 eights are again by 2, 6 are 4s are 8, 2 threes are 6, 2s are 4, 2 ones are 6, 6 are 12, 2 eights are 2 4s are 2 2s are and 2 1s. So here we have these two are in group of 3. These twos are also in group of 3. These twos are not in group of 3. Here we need 1, 2 more. So if we multiply 256 by 2, then these two will be also in group of 3. So answer is multiply 256 by 2 to make it a perfect square, cube, not square. So to make it a perfect cube, we have to multiply it by 2, right? Now, third question is, (72). So we will find out the prime factor of 72 first. So this will be, if we divide it by 2, we will get 3 is a 6, 6 are 12, 1 are 2, 8 are 16. Now it will be 9, 3 3s are 9, and 3 1s are. So here clearly 2s are in group of 2, group of 3, and 3s are in group of 2. So we need one more 3 here to make it group of 3. So if we multiply 2 by 3, it will become cube, right? Now part 4 of this question, 100. So if we find out prime factor of 100, so this will be 5s are 2s are 4, 5s are 10, 5 5s are, and 5 1s are. So here 2 is in group of 2 and 5 is also in group of 2. So we need 1 2 over here and 1 5 over here. So we need 2 and 5, right? That means 2 into 5, right? And 2 into 5 is equal to 10. So we have to multiply 100 by 10 to make it a perfect cube, right? Now question 3 is, find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. So previous question was, we have to find the number by which the number should multiply to obtain a perfect cube, and in this question we have to find the number by which the number should be divided to obtain a perfect cube. And part 1 of this question is, number is 81, Second number is 120. Third number is 135. Fourth number is 192. And fifth number is 704. So let's take first number. First number is 81. The process will be same. First we will find out the prime factors of 81. So dividing by 3 we will get 27. 3 will give 9. Again by 3 will give 3. 3 will give 1. So prime factors for 81 are 3 into 3 into 3 into 3. Right? So for cube, we should only have pairs of or group of 3. So here we have group of, but we only need group of 3 threes. So this is extra. So if we divide this by 3, this will cancel out and this number will become perfect cube. So answer is 81 must be divided by 3 to make it a perfect cube, right? Because this 3 was extra. We only need group of 3 prime numbers. Now second part of this question is 128. Now we will break this into prime number 128. So on dividing by 2, we will get 6 are 12, 4 are 8, 2 3 are 6, 2 are 4, 1 are 2, 6 are 12, 2 8 are 16, 2 4 are 2 2 are and 2 1 are. So prime factors of 128 are 2 times 2 times 2 times 2 times 2 times 2 and times 2, right? 3 3 and 1 extra. So 3 3 and this one is extra. So we have to remove this 2. So we will divide 128 by 2 to make it a perfect cube. Okay. Now part 3 of this question is 135. So part 3 of question number 3 is 135. We have to find out the number by which this number should be divided to obtain a perfect cube. So first we will find out the prime factors of 135 and this will be 3 4s are 12 and 5s are 15, 3 ones are 5s are 5 5 5 3s are right, 5 3s are 15. So we have prime factor of 135, 3 times 3 times 3 times 5. So here this 5 is extra. So if we divide 135 by 5, then 135 will be then it will be a perfect cube. Now part 4 is 192. So we will first find out the prime factors for 192. Now divided by 2. This will give 9s are 18, 6s are 12, 2 4s are 8, 8s are 16, 2 2s are 4, 4s are 8, 2 1s are 2s are 2 6s are 2 3s are 3 1s are, right? So prime factors for 192 will be 3 times 2, 3 times 2, 2, 2 and 2 times 2, 2 and 2 times 3. So here this 3 is extra. So if we remove this 3, so number can be a perfect key. So we will divide 192 by 3 to make it a or to get a perfect cube. Okay. Now last part of this question is fifth 704.